Hello, my amazing students. This is Mrs. A, and we are talking about 7.3, which is special factoring techniques. The first one of our special factors that we're going to talk about is factoring a perfect square trinomial. Okay, how do we recognize a perfect square trinomial? Well, the first term must be a perfect square, and the last term must be a perfect square. Then we take the square root of this term and the square root of this term, and we multiply them together, 5r, and we double it. And 10r is the middle term. Therefore, this is a perfect square trinomial. To factor it, all we do is put a plus in between here and put a square outside. Remember, when we have a binomial squared, this was back in 6.4. When we have a binomial squared, we take the first one and we square it. We take the product, 5r, and we double it. And we take the last term and we square it. And that's all there is to a perfect square trinomial. We'll factor into a binomial squared. Okay, so now we have a perfect square trinomial. We have an n squared and a 36, both perfect squares. If I take the n from that square, and I take the 6 from that square, and I multiply them together and double them, I do get a 12, but I need to have a minus in between to get a negative 12. And there we have the factors. First term squared, product doubled, last term squared. Okay, now we check this one. We have the first term is a perfect square. The last term is a perfect square. The square root of this one is 3x. The square root of this one is 4. The product is 12x. Doubled does give me 24. So my binomial's factors are 3x plus 4, quantity squared. All right, this is the first one that we have that doesn't look like a perfect square trinomial at the beginning, because although 4t squared is a perfect square, 28 is not. So let's factor a 2 out of the whole thing, okay? We can't factor anything else. So we factor out a 2, and we wind up with a 2t plus 3t minus 14, okay? So this one, even though we had a perfect square on the front, was not a perfect square trinomial, because when we pulled out a 2, we no longer have anything that has a perfect square anywhere. So this one is just one of those others thrown in to kind of trick you. The first term was a perfect square, but the whole thing didn't work out. So now how would we continue? We would go back to 7.2, which was our trial and error method. So we'll bring out our 2, 1, t, okay? So that's the only way we can factor 2. So we can go ahead and put that in there. Now 14, we could say is 14, 1, or 7, 2. Okay, I'm going to use the ones that are closer together, the 7 and the 2. If I put the 7 here and the 2 there, I'm looking for a difference. Okay, so I'm going to end up with 4t, 7t, the difference is 3t. I want my larger one to be the positive one and the other one to be the negative one, and those are the factors of that one, which did not wind up being a perfect square trinomial. All right, look at this one. The first thing we want to do is pull out our greatest common factor, which is a 9g. So when we pull out a 9g, what do we have left? We have a 1g squared, which is a perfect square, and we have a 2g, and we have a 1. Okay, so we have a perfect square on the front, a perfect square, 1 is a perfect square, on the back, and if I took the square root of this one, I get a g, the square root of this one, I get a 1, I multiply them together, I get a g, I double it, I get a 2g. So this portion here is a perfect square trinomial, and then I just put my greatest common factor on the front.